All right, now that we've dispensed with the ugly mess of trying to get rid of that old paradigm, we are free to move on to the new one. It's not that hard to do. All we have to do is say the exact opposite of everything in the old one, and we create a perfectly good and functional paradigm. However, that's not the goal. We talk about science. We talk about. I guess I've lost that, but we talk about the goal of science is to try and understand the logic of the universe, and we lay the ground rules. We're going to use philosophy, math, logic, that kind of stuff. In this case, the paradigm is to describe the genetic code, and we've described life as the physical manifestation of the logic of the universe, and genetic code is the mathematical language of life. It's a very big, broad, and ambitious statement and definition, but actually, paradoxically, it makes things easier. We can simplify better by going big, and we're going to do that down the line here. But I think it's important that we understand exactly what our goal is here, and I personally think that this book here, What is Life, Erwin Schrodinger, I agree with his idea. Ask the question, what is life, and then assume that the answer can be found in chemistry and physics, and then ultimately this answer will explain your own brain and your thoughts about this. So I love that. We have certain facts. I mean, we know that life exists. We know the universe exists. So now we have a timeline that we're going to have to play this game on. And ultimately, that's a brain. That's my brain. That actually looks a lot like my brain. Anyway, we've got everything in the universe. My brain's in the universe. We want to logically and mathematically explain how we can start with a universe that probably doesn't have anything in it. It's random, no information, whatever. And in some stepwise process, we end up with our brains. Well, first of all, we got to define the universe. And so I'll just define it as the thing that creates reality. So I think of it as a machine. So it's a machine that creates reality. And when I think about machines that do that, I think about a computer. So, like, if you sit down at your computer and you watch the screen, anything can come up on that screen. I mean, you could watch a movie, you could listen to music, you could read a book, you could do a simulation. You could simulate the solar system, whatever. All you can create reality on that computer, but in your heart that it's not real because it's just a calculation of information. So at the basement, all there is information, and by logically manipulating that information, reality gets generated. So I use that as my model for the universe. I say the universe is a computational machine, computer. Whether it's digital or not, we can debate that, but that's how I define the universe. So this computational machine starts out at time zero and it goes to now, and it generates my brain. So you got to start asking yourself, A, how is this possible? And B, how is it done? So these are atoms. So we're just going to round things off. T0 to now, that's 15 billion years. At some point, the universe generates atoms. Then at some point, we're just going to say, here comes Jack. At some point, it generates the Earth. Okay, I'm on Earth. So we go from 0 to 10 billion years. The Earth forms, and 5 billion years later, here we are talking about this. So this we're going to try and figure out a game that can be played, a computational game that can be played over these time periods that logically and inevitably will lead to um, our brains. So I just make a few simple assumptions. We know that quantum mechanics is the kind of logic and math that causes atoms. And we know that gravity is the kind of math that causes Earth. So we've got, on the very big side of things, we've got gravity. And on the very little side of things, the smallest scale, we've got quantum mechanics. Okay, and these are just mathematical models, constructs. Okay, and they're both based on geometry and symmetry and math that is non-Euclidean. In other words, Euclidean math is rectilinear, and then non-Euclidean math is spherical. So we got spheres here, we got spheres here. But they also create things that are called fields. Okay, so it's not like a linear equation, it's a collection of forces that create a field. I think of a field, I mean, there's a lot of different ways to think of fields. But I like to think of the ocean. You know, the ocean is H2O molecules, which happen to be tetrahedrons. They're constantly moving around. So the ocean creates a field, creates forces, and things then get moved around in that. So mathematically, that's how I think of a field. There's other ways too. But anyway, what we've got here is we've got a situation where we're talking about a force of nature at the low end and a force of nature at the high end. This happens to be continuous and determined. I mean, so the solar system is driven by the force of gravity, and it's continuous. And the solar system is a computer. I mean, it calculates, you know, minutes and hours and days and months and years. And okay, so it's an analog computer. And then at the bottom here, we've got this computational system that's discrete. That's why it's called quantum. It's based on the idea of probability. So what we do is we create a superposition. This is what Schrodinger did, the wave equation. So we say that there's all these possibilities, but the reality collapses to one thing. So we have a superposition of many things, and they always collapse to one thing. And it's based on probability. So we've got two forces of nature. One of them is discrete and probabilistic, and the other one is continuous and deterministic. And so life is not the smallest thing. Life is not the largest thing. It's something in between. So we've got a non-Euclidean field here and a non-Euclidean field here. And the goal in physics now is to create, these are two different fields. They want to create a unified field. So there's going to be a field in here that unifies quantum mechanics and gravity. So what that means is that mathematically speaking, the universe is doing one thing, logically doing it, and that one thing will explain gravity and it will explain atoms. And so I see these atoms as quantum computers because that's what they are. They're computing units of space. We can think of them as spheres or whatever, and they move around, that kind of thing. And I think of this brain as a computer, and it's a quantum computer because it's built out of atoms. So we've got this game where we're trying to go from zero to now, explain our brains with these fields. Well, I think that the best evidence in the universe for this unified field is life. I think that that whatever this, I believe in the unified field. I think that it's just a belief. I believe that there is one. I don't think that we're very close to finding it, but I do believe in it. So did Einstein. I mean, a lot of people do. It's not crazy to believe that. But it might be a little bit crazy to say that life is the example of it because Well, let's look at it logically. Whatever it is, the unified field, it must explain life because it has to explain everything. It has to explain quantum mechanics, has to explain uh, gravity. So what I like to do is I like to think that life must be based on a non-Euclidean uh, field. And so if this is a force of nature and this is a force of nature, then life must also be a logical force of nature. And so there must be these mathematical rules or properties in the universe that can explain how something so complex can actually happen. So when we get into the actual, we're going to have to invent, we have to invent all this stuff. Uh, so the main point is this. We got to understand what we're trying to do. People always ask me, they're like, how did you do that? Well, I'll tell you, it was easy. I'm just some jackass who stumbles from one thing to the next. I was a geologist first, and then I got a medical doctorate. So it's not like I'm not trained. It's not like I haven't learned stuff. But I am a jackass. I never take anything seriously. I always make everything up. After I went through my medical training, I taught myself computer programming. And it dawned on me that anything you need to know, anything you need to understand, you can understand with a computer. You can both simulate things, but you can also emulate things. And so I just decided that the universe was a computer, so I'm going to just start thinking about it that way. And it's amazingly helpful. It simplifies a lot. So when people ask me, well, how did you do this genetic code stuff? I'm like, it's easy because it fits in with my beliefs. All I have to do is just think about it, and it'll work. Now, the stuff that I'm describing now, I think you got to make definitions. I think you got to set goals if you're gonna describe an idea. I don't think they did that. But then you're gonna then have to start imagining things. I mean, it's all just imagination anyway. And some of these things that you have to imagine are truly radical. But I don't believe that everything I believe is true. But I do believe it's useful. And so it's useful to know what it is that I believe and how I did it. I think you could do it a bunch of different ways. I mean, that's what imagination is. I'm not saying that you're obligated to think these things or know them. What I'm saying is you're able to, you're invited. This is what science is. Once you release the shackles of this cult, see the difference between, I mean, am I a scientist? Sure, I'm a scientist. But the difference is I'm an amateur. I don't get paid to do this. I do it for fun. So I don't have to give a report. I don't have to, do grant proposals. I don't have to teach any classes other than this one. So that frees me up. I can think whatever I want. I can say whatever I want. I don't have to be accountable. The only thing I'm accountable to is, my own beliefs and the beliefs that my ideas work for my own enjoyment and entertainment. So I think that everybody should do this. I think this is how science is done. But that's what we're going to do. And the reason this is kind of a warning because when I go and start to describe some of these beliefs, they truly are radical, but they're radical because I'm going to try and simplify everything as much as I possibly can. I do that so that I can understand it. And ultimately what I want to understand is how it's possible that we can have a code of life that will go from total random nothingness to my brain thinking about how this happened. So, we'll dive into the radical ideas in the next video.